Hi, for this recording, I'm going to show you how to use Fourier Series to find a solution of a differential equation. In this case, the equation is d2x dt squared plus 3x equal to ft, where f of t is equal to 2t from t equal to minus pi to pi with period 2 pi. In this case, the first thing to do is find the Fourier series of the right hand side ft. So in this case, from the earlier hard work, we find that the Fourier series of ft is 4 times summation of n from 1 to infinity minus 1 power n plus 1 over n sine nt. After obtaining the Fourier series of ft, we replace the right hand side of ft by the Fourier series. Replace the right hand side ft by the Fourier series, so we obtain the differential equation d2x dt squared plus 3x equal to 4 times summation of n from 1 to infinity minus 1 power n plus 1 over n sine nt. Now, what we're going to do is we're going to use the method of undetermined coefficient to find the solution for each of the term and then add them up. And this is how it goes. So use the method of undetermined coefficient. Now, each term on the right hand side, sine nt for example, they are combination of sine nt. It does not appear in the complementary function of the homogeneous equation d2x dt squared plus 3x equal to 0. The complementary function is a sine square root 3t plus b sine square root 3t. So we can guess a particular solution x equal to summation of cn sine nt plus dn cosine nt n from 1 to infinity, just like in the case for undetermined coefficient. In order to find cn and dn, what you need now is to find out what is dx dt and d2x dt squared based on this x. So find dx dt and d2x dt squared. Now in this case, we must know that differential sine t is cosine t. Differential cosine t is negative sine t, and together with a chain rule, we will find that dx dt is summation of n cn cosine nt minus n dn sine nt. And d2x dt squared will be equal to minus n squared cn sine nt minus n squared dn cosine nt. Now we're going to put this x, dx dt and d2x dt squared into our original differential equation on the left hand side. So in this case, substitute x and d2x dt squared into a differential equation on the left hand side, and we obtain d2x dt squared will be this term, and d2 and x will be this term, and it must be equal to the right hand side. In order to find the cn and dn, we are going to compare the coefficient of sine nt and cosine nt. So compare the coefficient of sine nt. Now on the left hand side, coefficient of sine nt, we have minus n squared cn from the first term and plus 3cn on the second term. And on the right hand side, the coefficient of sine nt is 4 times minus 1 power n plus 1 over n. Therefore, we are able to find out what is cn now. So 3 minus n squared cn equal to 4 times minus 1 power n plus 1 over n, or cn equal to 4 times minus 1 power n plus 1 over n times 3 minus n squared. Alright, so we obtain what is cn. Now let's continue to find out what is dn. Again, the same equation, and now we're looking for coefficient of cosine nt now. So look for coefficient of cosine nt. In this case, coefficient of cosine nt is minus n squared dn, and dn here on the left hand side, and right hand side there is no cosine nt. So compare coefficient, get minus n squared dn plus dn times 3, almost forget the 3 here, is equal to 0. Since there is no cosine nt, since no cosine nt appear in right hand side, therefore dn must be 0 now. If you cannot see why dn is equal to 0, just take 3 minus n squared, dn is equal to 0. So dn is equal to 0 over 3 minus n squared, and so this is 0. So the Fourier series solution we have obtained now is x equal to cn summation of cn sine nt by dn cosine nt, where we have found out that dn is equal to 0. And what is cn now? Cn is equal to 4 times minus 1 power n plus 1 over n 3 minus n squared, as we obtained before. Therefore, this is the Fourier series solution for the differential equation we want to solve. That's the end of the recording.